Hello students, welcome to my channel Positron. Dear students, today I am beginning my journey with you all with the ray optics, right? The first topic that we are going to discuss that what light is. That is why the topic is light and its dual nature. Dear student, you know, and I am very sure that those who are studying physics must know the two people, Einstein and Newton, sir. Einstein, I think, the biggest scientist in 20th century. And the two famous discoveries of Einstein are photoelectric effect and theory of relativity. But the theory of relativity was so tough and people were very much confused. That is why Einstein was awarded with the Nobel Prize for the photoelectric effect, his work on the photoelectric effect in 1925. The day he was awarded with the Nobel Prize, those who are awarded Nobel Prize during the award, they have to deliver a lecture that is called Nobel Laureate. Dear students, in his lecture, Einstein sir I'm quoting Einstein sir, that he said, today I am going to achieve the biggest award in the physics, and for what? That I have told the world that what light is. But my friends, even today I do not know what light is. So how mysterious is the light that we are going to study? Dear students, topic name is light and its dual nature. What is the dual nature? You know, light behave like a particle and light behave like a wave. It behave both. It behave like a wave and it behave like a particle. Those properties of light which depends on the particle nature of light are reflection, refraction, scattering, dispersion. All these are the properties you will understand only when you suppose that light is made of particles. Or these properties, reflection, refraction, scattering, dispersion, these properties reflect the particle nature of light. Dear students, interference, diffraction, polarization, these are the properties which reflect the wave nature of light. Let's discuss something more about the light, that what light is. You know, the waves are basically divided into two types. One is a transverse wave and there is a longitudinal wave. Transverse wave is what? A wave which travels when a wave is moving, and if the particles of medium used to vibrate perpendicular to the propagation of wave, then such a wave is said to be the transverse wave. For example, let a wave is moving in this way, right, in a positive x direction, and the particles of medium begin to vibrate perpendicular to the propagation of wave like this. So in 360 degrees, there are infinite vibrations of light are possible, and such a wave is said to be the transverse wave. And our light is a transverse electromagnetic wave. Our light is a transverse electromagnetic wave. Dear students, second type of wave is a longitudinal wave. Longitudinal wave is what? When wave is traveling, the particles of medium coming in the way of the wave begin to vibrate along the propagation of the wave. In transverse wave, for example, our light is a transverse wave. Particles of medium used to vibrate perpendicular to the propagation of wave, whereas in the case of longitudinal wave, particles of medium used to vibrate along the propagation of the wave. For example, light is a transverse wave, radio wave, ultraviolet wave, X-ray, right? Microwave. All these are the electromagnetic waves. You must will study in further chapters the electromagnetic spectrum. Dear student, the example of longitudinal wave is a sound. The motion of sound in air is the best example of a longitudinal wave. Dear students, longitudinal wave or mechanical wave cannot travel in the absence of medium, but our light has a property that it can travel even in the absence of medium. From just I said that light is a transverse wave. Transverse wave travels in form of crest and trough. Transverse wave travels in form of crest and trough. Crest a point of maximum intensity and trough, this is crest, this is the crest and this is the trough. Dear students, crest is a point of maximum intensity, whereas trough is a point of minimum intensity. This is a, this is a sinusoidal wave, right? Y is equal to A sin omega t or Y is equal to A cos omega t. Simply it represents a wave, right? So, what I said that the transverse wave travels in form of crest and trough. Crest is a point of maximum intensity, whereas trough is a point of minimum intensity. Dear student, sound is an example of longitudinal wave. It travels in form of compressions and rarefactions. Compression is a point corresponds to the point of maximum pressure, whereas rarefaction corresponds to the point of minimum pressure. Now, dear students, a lot more we have to discuss about the light. From sun to the earth, light takes approximately 8 minutes to reach, right? From sun to the earth, light ray takes approximately 8 minutes to reach to the surface of the earth. Dear students, for example, you represent a wave y is equal to A sin omega t, kx minus omega t. This is a simple representation of the wave where y is what? Displacement at any instant t. A is what? Maximum displacement, that is said to be the amplitude. K is what? K is the propagation constant. It is expressed as 2 pi upon lambda, and in form of vector you can represent 2 pi upon lambda n cap. Omega is the angular frequency that is represented by omega is equal to pi. Dear students, why I am discussing this? That how the light is also a wave. Light is an electromagnetic transverse wave which has a capability to travel even in the absence of the medium. And you know that Einstein has said, Einstein theory of relativity says that the velocity of light is the maximum possible velocity. Nothing in this universe can supersede the velocity of light, and you know the velocity of light in vacuum is the maximum, and that works in the vacuum. Velocity of light is that is 3 into 10 raised to 8 meter per second, right? This is the maximum possible velocity of any object in this universe. Anything, any object, nothing in this world can supersede the velocity of light. This is the Einstein theory of relativity, and c is equal to 3 into 10 to the power 8 meter per second. Dear students, if you want to find this value, c is equal to, you must have gone through the electrostatics, electricity, magnetostatics. The two constants you come across, one is a mu naught and there is epsilon naught. Mu naught is a permeability of the free space, whereas epsilon naught is the permittivity of the free space. So c is equal to actually mu naught epsilon naught. These two quantities are very relevant in the electromagnetism, and c is equal to, you can write like this, 1 upon just multiply by 4. This is mu naught, multiply and divide by 4 pi, and this is 4 pi upon 4 pi epsilon naught. C is equal to 1 upon, root mu naught upon 4 pi is what? Mu naught upon 4 pi, that is equal to 10 to the power minus 7 in MKS, and 1 upon 4 pi epsilon naught is equal to 9 into 10 power 9. So 4 pi epsilon naught, that you might write 9 into 10 to power 9. Dear student, bring it to denominator here, it will turn out to 9 into 10 raised to power 16, and when you will just reverse it, it will be under root 9 into 10 power 16 or 3 into 10 raised to power 8 meter per second. Now just I have shown you that how the mu naught and epsilon naught are relevant while finding the velocity of light in the vacuum. Velocity of light in the vacuum C is equal to 1 upon root mu naught epsilon naught. Mu naught upon 4 pi, mu naught is a constant that is used in the magnetostatics, whereas epsilon naught is a constant that is used in the electrostatics. So in this way you can find out, just replace the values of mu naught and epsilon naught, I have multiplied and divided the equation by 4 pi, so you can get the value of mu naught upon 4 pi. You are familiar with this value, that is 10 to the power minus 7, and 1 upon 4 pi epsilon naught, that is equal to 9 into 10 to the power 9. Just replace the values and you will get. Dear students, what will you do if you want to find out the velocity of light in a medium, in a material medium? Then this mu naught and epsilon naught, mu naught will be replaced, actually C is equal to 1 upon root, this will be mu into epsilon, right? This will be mu into epsilon. Now mu is a permeability of that medium, epsilon is a permeability of that medium. In this way you can write and you can find out the velocity of light in any medium. Velocity of light undoubtedly less than the velocity of light in vacuum. Velocity of light in vacuum is the maximum possible velocity, right? Now dear students, too much I discussed about light with you all. The dual nature is what? Again I am repeating my words. What is the dual nature? That sometimes light has a capability to behave both as well as particle as well as wave, right? Those properties, for example, reflection, refraction, dispersion, scattering, all these properties reflects the particle nature of light, whereas interference, diffraction, polarization, all these properties reflect the wave nature of light. Now dear students, as discussing with you all that light is an electromagnetic wave, in further topics you must will study the electromagnetic spectrum. When we say light, actually, then what is in our mind? We say the visible spectrum, means we are talking about the waves here. Actually, white light is comprising the 7 colors that is referred by waves here: violet, indigo, blue, green, yellow, orange, and red waves here. This spectrum has the wavelength ranging from 4000 angstrom to 8000 angstrom. Now, dear students, beyond that, also there is an electromagnetic spectrum. Just I said that is gamma rays, X-ray, ultraviolet, radio waves, microwaves, your spectrum, so on. Now, what we have to discuss, very important, that how the light can be represented. Why it is called to be the electromagnetic wave? What is means of electromagnetic wave? Dear students, how the electromagnetic wave can be originated? Dear students, I am very sure, because this is the second book I am going through and you must have gone through the electrostats and magnetism. I am very sure. You must have studied a lot, that is Gauss law in electricity. I am just why I'm just discussing all this during the chapter of light, just I want to connect all these, right? And now you will see that all these are connected. Actually, in initially in the 19th century, electricity was a bit, it was supposed that electricity is a different topic and magnetism is a different topic. But in the 20th century, in last of 20th century, we came to know that electricity and magnetism, they are not apart to each other, but they are connected to each other, right? And how they are connected? Look here, you must have studied a lot, that is Gauss law in electrostatics. Gauss law in electrostatics is what? that is integral E dot ds is equal to q upon epsilon naught. You must have studied. What it means of this? This law says that wherever there is a charge, there is an electric field. The means of this law, integral E dot ds is equal to q upon epsilon naught. Means of this law is that wherever there is a charge, there is a field, right? This law does not explain whether the charge is static or moving. It does not matter. If charge exists, a field exists. It means charge is the only source of electric field according to this law. Second, I am taking another law I am referring, that is Ampere's circuital law. Ampere's circuital law. Look here. What is Ampere's circuital law? That says integral B dot dl is equal to mu naught I. Means this law, how will you explain? Integral E dot ds is equal to q upon epsilon naught. Means electric flux associated with a closed loop is equal to 1 upon epsilon naught times of charge enclosed in that loop. How this law you will explain? Integral B dot dl is equal to mu naught I. It means line integral of magnetic field B dot dl. Line integral of magnetic field over a closed loop is equal to mu naught times of current enclosed in that loop. Again I am discussing. Again I am just trying to explain your integral B dot dl. It is a dl. That is why it was a E dot ds. Any flux, either be the electric flux E dot ds, magnetic flux B dot ds, right? Any or gravitational flux, whatever be the flux, if it is any flux is a dot product of that physical quantity with the area vector. It is an electric flux, so E dot ds, dot product of area with the electric field. If it is magnetic flux, then it is a B dot ds, right? So here it is a electric flux associated with a closed loop is equal to 1 upon epsilon naught times of charge enclosed in that loop. This is the Gauss law in electrostatics. How this law? How will you explain this law? Line, it is a dl. Line integral of magnetic field over a closed loop is equal to mu naught times of current enclosed in that loop. Dear students, can you connect these two laws? Yes, you can. How? Look here. Integral E dot ds is equal to q upon epsilon naught. How do I explain this? That wherever there is a charge, there is a field. Means charge is the only source of electric field. This law do not refer whether the charge is static or moving. And in this, integral B dot dl is equal to mu naught I. Means line integral of magnetic field is equal to mu naught times of current enclosed in that loop. Means current is the only source of magnetic field. Wherever there is a current, there is a magnetic field. Current is the only source of magnetic field. Now, how will you connect these laws? You know the rate of flow of charge is called current. If the charge is flowing, it will create the current, and that current will result into a magnetic field, right? Now, integral E dot ds is equal to q upon epsilon naught. This is the Gauss law in electrostatics. It do not explain whether it do not refers whether the charge is static or moving, right? If there is a charge, there is a field. According to this law, Gauss law in electrostatics, if there is a charge, there is a field. It means charge is the only source of electric field. In the similar way, Ampere's circuital law says that if there is a current, there is a magnetic field. Means current is the only source of magnetic field. And how the current is produced? Rate of flow of charge is called current. It means the charge in a motion creates a current, and that results into the magnetic field. Now, dear students, how does it is related with the electromagnetic wave? Just you said that if a charge rate of flow of charge is called current. If a charge is in motion, it will create the current, and that will result into the magnetic field. Now, the motion of the charge may be of two types. It can move in two types. either with the constant velocity or with the accelerated motion, right? The charge can move in the two ways, either with the constant velocity or with the accelerated motion. If it is moving with the constant velocity or with the accelerated motion, in both the condition, if it is moving, it will create the current, whether it is moving with the constant velocity or its motion is accelerated, there's no matter. But if if the motion is accelerated, then not only it will create the electric field, not only it will create the magnetic field, but it will give birth to a wave that is called to the electromagnetic wave. For example, charge is the only source of electric field, current is the only source of magnetic field. In the similar way, accelerated charge is the only source of electromagnetic wave. Electromagnetic wave is produced by accelerated motion or accelerated charge. Accelerated charge, how will you get? How will you get the accelerated motion? Very simple. Any body which is oscillating, its motion is accelerated motion. If a charge is oscillating, then its motion is always accelerated motion, right? So best example is that how will you recognize whether a motion is accelerated? Then if it is oscillatory motion, vibratory motion, then undoubtedly it is accelerated motion. Dear students, electromagnetic wave is not only produced by accelerated motion but also received by accelerated motion of the charge. The electromagnetic wave is not only produced by accelerated motion of charge but also detected or received by accelerated motion of charge. Now it means that the electromagnetic wave had electric and magnetic vector as well as. Now how you can say, right? How you can show this, that electromagnetic wave or your light wave or your visible spectrum, how it is consisting the electric and magnetic vectors. Dear students, light is characterized by three vectors: vector E, vector B, and vector K. Vector K is called to be the propagation constant. Just as I said you that K is equal to 2 pi upon lambda n cap, right? You can write K is equal to pi upon lambda n cap, right? K is a propagation constant, E is a electric vector, B is a magnetic vector. Now, dear students, these are the three vectors which characterizes any electromagnetic wave as well as your light also. Now, for example, if the light is moving, your light wave, your concerned electromagnetic wave is moving along x-axis. Then the rest two vectors, vector E and vector B, either one will be along y-axis and the will be along z-axis. And as soon as light is moving, these three vectors are mutually perpendicular to each other like this, right? These three vectors, let light is moving in this way, then it might be electric field, then it will be magnetic field. If it is electric field, then it will be magnetic field. And now let your light is moving this way. Dear student, if light moves, then these three vectors actually used to rotate, right? These three vectors, vector K, vector E, vector B. Vector E and vector B used to rotate around the vector K in such a way that three vectors remains mutually perpendicular to each other. Let light is moving this way, then the three vectors will rotate. These two vectors will rotate about vector K in such a way, because vector K is a propagation constant that represent the direction in which light is moving. Now, dear student, so it is a vector K is the direction in which light is moving. It is a vector E and let it is a vector B. These two vectors are rotating about vector K in such a way that three vectors mutually remain perpendicular to each other, right? I hope that you people are following. Now, dear students, how these vectors can be represented in an electromagnetic wave? Just as I said that you represent a plane progressive wave, y is equal to a sine omega k into x minus omega t. Either you write y is equal to a sine omega t minus kx, some books write a sine omega kx minus omega t. There is no difference in these two equations. There is no change in the nature of electromagnetic wave. You can write a cos kx minus omega t. Dear students, you know either a sin omega t or a cos omega t, both are the sinusoidal equation. In general, we say the electromagnetic wave is represented by a sinusoidal equation, right? So either you write with the a cos kx minus omega t or a sin kx minus omega t. There is no difference. If you want to plot, you can see this is a y is equal to a sin omega t graph, right? And this is a graph of s y is equal to a cos omega t. So both the graph are similar. Only the difference is that at t equal to 0, this graph begins from the origin, and this graph at t equal to 0 begins from the maximum. There is only the difference. Now, dear students, how the electromagnetic wave, I mean that how light can be represented in the form of this equation, because light is a wave, electromagnetic wave, right? And electromagnetic wave is consisting that it is comprising the two vectors, vector E and vector B. How in terms of vector E and vector B light can be represented? Now look here, vector E is equal to, you can let light is moving along x-axis, and that is why I am considering the electric field vector along y-axis and magnetic field vector along z-axis. Now Ey is equal to, as y was the displacement and a was the maximum displacement, that is why, and that was called to be the amplitude. Here Ey is the electric field, and so maximum value of electric field, that is electric amplitude, it is called electric amplitude here, that is sine k into x minus omega t. Light is moving along x-axis, whereas its electric vector is along y-axis, and the magnetic vector in the same way you can write Bz is equal to B naught. This is a magnetic amplitude, and again it is a k into x. This x is not going to change. Actually, it is representing the direction in which light is heading. So it is Ey is equal to E naught sin kx minus omega t, and Bz is equal to B naught sin kx minus omega t. Now, dear students, from this equation, it is clear that these two equations are representing the light, that light is an electromagnetic wave, has an electric and magnetic vector both. Ey is equal to E naught sin kx minus omega t, Bz equal to B naught sin kx minus omega t. It means light is heading towards x direction, and electric field is along y-axis and magnetic field is along z-axis. This is called to be the electric amplitude, and it is called to be the magnetic amplitude, and these two vectors are related in this way. B naught is equal to E naught upon C. This is the relation between the two vectors, electric amplitude and magnetic amplitude. In this way, you can represent the light, right? From these equations, it is clear that k into x means light is heading towards the x-axis. So, dear students, this is the way I have discussed with you all that what light is, right? So, light is what? Light is a transverse electromagnetic wave. It has a wave nature and particle nature both. The properties depends on the particle nature. Ray optics is basically ray optics consists those properties of light which are based on the particle nature. For example, reflection, refraction, scattering, dispersion. These are the properties of light you can explain when you suppose that light is made of particles. Made of particles means made of photons, made of energy packets. Photons are energy packets. And dear student, those properties which are based on the wave nature of light, for example, interference, diffraction, polarization, right? These properties you can explain when you assume that light is made of wave or light behave like a wave. Dear students, just I said that the three properties I have discussed, the three properties which are based on the wave property of light are interference, diffraction and polarization. Dear students, sometimes it is asked that which one is the polarization vector of light. It is actually only electric vector is polarized. Magnetic vector is not polarized. Only electric vector is polarized. That is why vector is also called polarization vector. Just I said that Ey is equal to E naught and Bz equal to B naught. It means light is comprising, consisting electric and magnetic vector both, and only electric vector is polarized. That is why it is called to be the polarization vector. Now, dear students, this is the way I discussed with you all that what light is. Light is a transverse electromagnetic wave, has particle nature and wave nature both. Ray optics is that part of optics in which we study those properties of light which are based on the particle nature. For example, reflection, refraction, scattering, dispersion, etc. And wave optics is that branch of physics in which we study the wave nature of light. For example, the properties of light, interference, diffraction, polarization, etc. Right? From sun to the earth, light comes approximately in 8 minutes. Right? So, after that, dear students, the next video will consist the reflection of light from plane mirror, from uh, spherical mirror, and reflection and refraction of light. Both the topics I will cover in the next video. Till then, meet you in next video. I hope that my videos are going to be beneficial to you. If you think so, that my videos are helpful to you, then please and please like, subscribe and share, and do comment on my videos. Thank you.